All right, good afternoon, everyone. I'm Mike Huber, Director of Technical Support here at Alliance, and I'd like to welcome you to our Gator studio here in New Jersey. Fortunate enough to have Eric with us. Eric's our Chicagoland rep.
Yep.
It's a wealth of knowledge. All of our reps are a wealth of knowledge. And you reading a book over there? You write a book?
I am. So some of you guys remember this series, the For Dummies series. We thought about publishing this book and putting it up for sale, but we figured this would be a much more economical way to bring this knowledge to you. It was live from our Gator studio.
Yeah, they wanted way too much money to license that brand. So you're going to get us live today. We're going to walk through a little bit of the, who, what, where, when, and why of polymeric sand installation. So we want to take a look at the background here, and then we'll get to the actual installation. And at that point, you'll have a pretty good understanding of why those installation points are so important.
That's right.
First thing that we're going to tackle right off the bat, every now and then, contractor calls us up and says, hey, my polymeric sand doesn't work, or we get an email like this one.
Yep, this happens with every territory manager with any company in the industry here. But basically, you can see here, get an email. Polymeric sand I installed doesn't seem to be working right. I think I have a bad batch.
Oh, the old bad batch. Huh?
Our job as territory managers is to come out and try and figure out what went wrong on that installation
And come up with a solution to fix it, right?
So,
but hey, we're much more interested in addressing the problem before it happens, right? So hopefully you can gain some knowledge here that prevents you from having to send that email, from having that issue. So first of all here, what do you think a batch of polymeric sand actually is?
Right.
Is that, what do we mix up 5 bags at a time in a kitchen mixer?
Yeah. We have a poll here. We're going to be, we want you guys to tell us what you think a batch of polymeric sand is.
All right, so we've got our options here. What do you think? 1 pallet?
1 pallet?
5 pallets?
5 pallets?
10
pallets?
15? Let's see what everybody's thinking here.
So just to keep in mind, 15 pallets is about a truckload of sand. So think about that when you're answering the question here.
And then let's think about other industries too, right? Like, hey, everybody buys milk.
Right.
So when you go buy milk at the grocery store, you buy your milk, you take it home, and you expect to drink it and for it to be good milk.
Yeah, you don't want it to be spoiled.
Hey, 9 times out of 10, 0.999% of the time, that milk is good. But hey, every now and then something goes wrong. Yeah. Polymeric sand's no different, right? We do our very best to make sure that we're producing a quality product and that it arrives to your job site in ready-to-use form.
Exactly. So looking at the poll results here, it looks like the majority of people are under the impression that 15 pallets is a batch of sand.
Well, they're actually way off. It's much closer to 1 pallet. It's a little bit less than 1.5 pallets, actually, Eric.
Yeah.
So every 1.5 pallets that we're producing is a unique batch, and we're doing quality control testing on that. We're making sure that that product is perfect. In fact, when we batch up polymeric sand, we're taking samples of each batch. We're actually running some tests on those samples, and we are making sure that those tests come back and say, hey, this polymeric sand is working the way it's supposed to, before we move that production lot into our inventory. Yeah. So that's really important to us.
We want to go through continuous testing to make sure that what we're putting in those water-resistant bags onto the pallet and eventually shipping out to our customers is good product.
So once we have that product that we're certain is good, right, we double wrap those pallets. They're stored in our yard outside all year round. They are very weatherproof and waterproof. You know, we ship those out to the dealer, and all right, we don't have control over everything that happens from our plant just north of Montreal, Quebec, Canada, to your dealer and to your job site. So it is quite possible that there could be a small hiccup along the way. If you ever get a bag that's, say, hey, half wet, what are you going to do, Eric? You just throw away the wet stuff and use the dry stuff?
No. If you get a bag from your supplier, whoever it may be, that has a little bit of moisture in there, has some chunky sand in there, do not use that product. Quarantine that product, give your rep or your supplier a call, and let's handle it on a case-by-case basis. But don't try and separate that damp sand from the dry sand in the bag.
Right. The main idea is that, hey, we control the manufacturing of our product. We don't outsource it to anyone else. We do our best to make sure that you get a quality product every time you buy a bag of Alliance polymeric sand, and we want to make sure that you have success with it. So don't use that wet bag of sand. That's setting yourself up for failure there. So we produce that great polymeric sand. how does it work? What's
Right.
polymeric sand supposed to do?
Right. So polymeric sand is designed to resist weeds, resist insects, and resist erosion. It's not designed to set up like a mortar. So,
But I hear that all the time. This polymeric sand's not rock hard.
Right.
It's supposed to be like concrete.
right. So polymeric sand, as it dries, it cures. As it gets wet, it does become flexible.
All right, so let's take a look at some wet polymeric sand, right? This was a hard, solid block, but you can see it's kind of become rubbery and soft and flexible. And that's a desirable quality in polymeric sand, right? We're installing this in interlocking concrete paver systems.
Yep.
And what do interlocking concrete paver systems do?
Right. They're going to move.
Right, whether that's from loading, whether that's from freeze-thaw, whether that's from natural flexion, you are going to get some movement in your hardscape project, and having a flexible joint material can be one great way for a long-lasting, durable solution in between those pavers. So flexibility is fantastic, but there are some characteristics of polymeric sand that can potentially become problematic, and that can be due to environment or installation. And one of those is the thickness of the crust.
Right. So polymeric sand is designed to form a crust. Now, ideally, that crust is a ½ inch to an inch, maybe even an inch and a half in a best case scenario. But
you typically don't see that polymeric sand joint harden from top to bottom because it's always wet and damp underneath. So, hey, if you've got a crust that looks like this, you've got a problem, right? That crust is way too thin, it's prone to damage. Now, that can come from either a very, very wet environment where everything underneath is staying damp and it's only that top layer that's exposed to the air and the wind and sunlight that's working properly, or it can come from the installation process, right, Eric?
Right. We'll get into the installation process a little bit later, but when it comes to activation, if we don't get enough water down, you can form a very thin crust like that.
So we want to make sure we water that nice and deep. We're going to end up with a crust that might vary from, an inch and a half to an inch or so. That's going to give you a very long-lasting, durable, resilient joint.
Yep.
And polymeric sands, we just showed you that, flexible piece, they do cycle. So in a wet state, they're soft. In a dry state, they're hard. What does that mean on a real job site?
Right. So when you first activate the sand, everything's wet, it dries out. It's going to harden. As we go through our weather cycles and you get some rain, it's going to soften up a little bit. But as it dries, it's going to self-heal and eventually cure to a stronger end product.
Right, so we've got wet, dry, wet, dry, wet, dry. We've got flexible, softer, hard, when dry, and that cycle can happen a million times. However, if it doesn't cycle, if it always stays wet, we've got a problem. It's no different than, say, growing corn. If you grow corn in a field, well, sure, it gets rained on, the ground gets wet, that's great, corn likes that. If you get a flood and that field is underwater for a month, what happens?
Well, you're not going to get very much corn out of that field.
Right, and the same goes for polymeric sand. We need that wet, dry cycle to happen. And it is possible that on a specific job site, if you don't take into account the characteristics of that job site, the way water may move or not move, you could have a moisture-related issue. So what happens when you dig a hole, Eric?
Right, so you dig a hole, you're taking dirt out of the ground. That void is naturally going to want to fill with water, whether it be for groundwater, rainwater, whatever the case.
Or
may
a
be.
hardscape project
Or a hardscape
excavation,
project,
right?
yeah.
These guys were out there, they dug out this walkway, and they were probably getting ready to put in the base material and put in their pavers, but I don't know, maybe before they got a chance to put in their base material, we got a rainstorm and this got flooded, right?
Yep. So what happens when we see this walkway that's flooded here? You can see they excavated properly, but they didn't give that water any place to go. So whether it rained overnight or whatever the case may be, that water is now trapped.
And that's a bad thing, right? I think we can all agree. Pavers aren't going to like that. The base material's not going to like that. The polymeric sand's probably not going to like that.
Water and moisture is the enemy of a hardscape project.
So that could be clay soils that were causing that issue. Another issue that we see, even in good soils, would be the use of the wrong fabric underneath a hardscape project.
Right. We manufacture different types of fabric. We have a woven fabric and a non-woven fabric.
Well, that woven fabric's the strongest. That's the best, right?
It's strong, but unfortunately it doesn't drain. So even if you're using it in the right application, you have to give that water someplace to go if you're using a woven fabric.
Right. With a woven fabric, you're not going to get any permeation to the ground. You need to have a drain to daylight or something along those lines. And that woven fabric is this kind of shiny, plasticky type fabric that almost looks like a lattice work there. Now, what would we like to see? as a
Well,
fabric.
you want to see a non-woven fabric to allow any water that gets in there to then drain down into your subsoil.
Right, so that non-woven fabric's more of a felt-like material. So I hear guys say a lot of times, hey, I've got to use that woven fabric because it's the strongest. But in most residential hardscape projects, you're better off having the adequate strength of a non-woven fabric and the permeability, because getting that water out is really key.
Right, and again, we go back to the beginning. If that water can't drain, that water is stuck in there, it's going to try and take the path of least resistance, which is up through your joint
So
material.
I just poured water on that woven fabric.
Yep.
When's it going to drain?
It's going to take quite a while if it ever drains at all.
Right, so that's just sitting on top of there. So unfortunately, that's not going anywhere. Now, here's our non-woven fabric. Well, that seems to be draining right through very nicely.
So same thing as, basically here we're simulating your hardscape project. When that water does work its way down, it needs to be able to evacuate out of that project.
Right, so let's make sure that we're taking into account the characteristics of that job site. Are there clay soils, poor draining soils? Here's a hybrid base project, right? Hybrid base is supposed to be free draining.
Yep.
Why do I have all that water in my free draining?
It's free draining. That water is going to work its way down through the stone, but unfortunately, again, we go back to giving it somewhere to go.
All right, I see a comment. Put some gravel on top of the woven fabric. It will drain. It will drain a little bit better, I agree. Maybe not quite the most fair test having it suspended in the air here, but the actual flow rate for our non-woven fabric is give or take 80 times higher than our woven fabric. So keep those relative measurements in mind there. All right, so that's the fabric. Keep in mind, you need to let water out of your system, whether it's a traditional base, a hybrid base. Use the right fabric, use a drain pipe to daylight. The base material will perform better. The pavers will have less efflorescence, and the polymeric sand will certainly last longer.
The idea is we don't want any of that base material or that bedding layer to stay consistently damp.
All right, so speaking of bedding layer, let's take a quick poll here and see what our audience is using for a bedding layer. We've got people all across North America here. ICPI typically says use a concrete sand, ASTM C33, as your setting bed layer. But there's also stone dust screenings.
Stone dust screenings. More and more, the open graded hybrid base is becoming popular.
That clean chip idea is becoming very popular. The aggregate doesn't freeze. It's free draining, easy to screed out and work with. So a lot of benefits there. In fact, it looks like the majority of our audience is doing the clean chip setting bed.
Yep.
All right, so let's see. We got about, give or take, a quarter using concrete sand, 20% using stone dust, and 60% using clean chip. Well, let's take a look at this video that compares all three real quick. You can see the stone dust there. Well, it's getting wet, but very quickly begins to back up and water ponds on top.
Right.
Sand draining, pretty well.
But that clean chip on the bottom, you can see that's draining basically straight through there.
Yeah, that's fantastic. The water's really going through that clean chip like nothing. So that's pretty impressive. Really do like having that happen.
Yeah. What we will say is if you are still using that stone dust option, consider migrating away from that, because that is going to hold water much more than either of the other two alternatives.
Yep, and again, it's the same idea as choosing the right fabric. Choosing the right setting bed material can help keep the pavers drier, minimizing efflorescence, and help that polymeric sand joint cycle properly and perform for years and years to come, as opposed to being soft and wet and vulnerable and growing moss, mold, and mildew. All right, so we've got a few different concepts here. The one concept that I want to talk about, and the one thing that I hear pretty frequently, we've got a 1,000-square-foot patio, and there are a dozen spots that just don't seem to dry out.
Yeah.
Those dozen spots must be bad polymeric sand, bad batch in those 12 spots, right?
Right. You have certain areas in the patio where the polymeric sand isn't drying like the rest of the patio is, and a couple things could be going on there, but it's really important to investigate and look into why those areas are the way.
Right, so one very simple option you can see on screen here on our little pad is that you may just have a little bird bath, right? A depression in your pavers. So if some area is settled and you can have water pool and pond on the surface, that area stays wet for a longer period of time, and, well, the joint stays wet for a longer period of time.
And the longer that joint stays wet, the less life you're going to get out of that polymeric sand in there.
All right. So another potential issue here, we've got pavers on the top here. And these pavers, well, they've got the proper slope, right? Water can shed right off of that. Surface looks pretty uniform, no bird baths in the pavers. We've got our setting bed, whether that's sand or chip. That also looks, well, pretty uniform, right? Sloped off the same
Probably
direction.
2% slope is...
But what happens when we get down to our base? They didn't slope their base the same way they slope the pavers.
Right, right. So what we have here, what that's leading to is an inconsistent depth of that bedding layer. And the problem with that is the different depths of that bedding layer are going to hold moisture at different rates.
Or you could potentially have an area that was a depression in your base where water gathers underneath, creating a subsurface, a subterranean puddle. And as that water sits underneath, well, it wicks up to the surface, keeping that joint wet for prolonged periods of time. So it's important to, one, pitch your base off the same way you're going to pitch your final project, maintain that same slope, and then use a uniform layer of bedding material, whether that's concrete sand or a clean chip. And that way you're going to minimize any potential for water to gather underneath your project and keep that joint area wet where it does puddle or pond there.
So what happens when that joint does hold moisture?
Well, sometimes when polymeric sand stays wet for a prolonged period of time, it grows moss, mold, or mildew. Eric, if you were lost in the woods and had to find your way home, what would you do?
The book says you look at the
You'd probably sit down and cry, right?
North side of the tree, yeah.
You look at the north side of a tree and there's moss growing on it. Same thing happens on pavers, right? Really shady areas, north side of a house. Well, if it doesn't dry out well, if it doesn't get sunlight to help that drying process, then oftentimes you're going to get moss, mold, and mildew. And that's not a polymeric sand defect or issue. It's a sign that it's a wet, moist environment.
And what happens is as that moss does grow, again, it's holding moisture in that polymeric sand joint. Right.
It's actually keeping that wetter than it normally would be. So it's causing even more problems. Right. But there is a quick trick to get rid of moss, mold, and mildew, and that is to use pool shock. So pool shock's available in a powdered bag or in a gallon jug, and it's a very strong bleach, basically, a sodium hypochlorite solution, almost like a magic trick. Mix up that 1 gallon container or 1 pound sack of pool shock in a 5 gallon pail, spread that liquid over your paver surface, and within minutes, that moss, mold, and mildew begins to die, and it's great for leaf stains, tannic acids, berries, things of that nature too.
And what that's going to do is it's going to kill that moss and whatever that organic growth is and help to allow the joint to properly dry.
So I think the main idea here with the job site is just go into it assessing where moisture might come from and how moisture is going to leave, whether that's drainage pipes percolating into the soil, air and wind and sunlight movement helping to dry things out, the proper pitch of your base and setting bed and final surface to make sure that your construction project, this hardscape project, is going to drain and allow that polymeric sand to cycle.
So we addressed moisture, the construction. How about we talk about the actual installation of polymeric sand?
Well, that's what we're here for, right? We really wanted to hit the installation, but we thought that would be great background information for you. All right, real quick question. Will pool shock hurt the pavers? Pool shock will not hurt the pavers.
Right.
The pool shock is a strong bleach solution, but the iron oxide pigments in pavers are completely unaffected by it. I've never found pool shock to affect anything around a patio, so it's going to be relatively safe on the grass, the plants around that. I would certainly be careful of any fabric cushions or something along those lines, but it is pretty safe. Obviously, water down plants and garden beds beforehand and afterwards, and rinse well. All right. Back to the installation, right? We got a little sidetracked there, but now we're going to get into the installation. So, installation.
What are you looking at there?
I'm leafing through the manual for this new skid steer I bought. Wait a minute, I'm not going to look at this.
Yeah,
Forget that, right?
We don't need the instructions here.
We don't need the instructions. That's the attitude many of us have. You're not going to look at the instructions unless you have a problem, but in some cases, hey, maybe it is better to figure out the right way to do something before having an issue. So we're going to walk you through basically 4 easy steps for polymeric sand installation, talk to you about why they're important, and products change over time. You know, the skid steer I bought 15 years ago came with a 10-page instruction manual, and that thing's like 400. So as products evolve, instructions evolve. You know, for example, the G2 from Alliance, well, that requires 1 watering instead of the old 3-step process. And brand to brand, things can be different, right?
Well, that's the thing. If you're switching brands from one polysand to the other, those installation instructions are going to be different. But also, the sands within our own product line have different installation instructions as well. That's why it's very important to actually read the installation instructions and know which product you're installing.
Yep, that's a great point. You know, like we said, G2 and regular Super Sand, or G2 Max and regular Max, have different installation instructions. And then Gator Dust, Eurostone, and Nitro all have, you know, similar but slightly different installation processes in order to obtain the best results. So a little bit of effort, you know, beforehand goes a long way in making sure that your project is going to be successful. So when we get out to do a hardscape job, we've got all our pavers installed, our natural stone installed, we're ready to put down our polymeric sand. So obviously, first of all, we need to have a dry surface, correct?
And that's not just the surface that has to be dry. You want your bedding material underneath to be dry as well.
Right. If you start, you know, installing your sand and it's wet underneath, well, that moisture is going to start wicking up immediately. If the sides of your paver are super wet, it's going to start activating that polymeric sand right away. And you're not going to be able to get that sand down into the joints to fill it from top to bottom and densely compact it before it's beginning to activate.
Right. So as long as your project is completely dry, that bedding layer is dry, your first step is opening the sand and sweeping it in.
All right, so you open up that sandbag, and you don't have to flip the sandbag over and over to, you know, mix it up. The polymers aren't going to separate from the sand. You know, dump it out, start spreading it around, and you don't have to sweep it cleanly at first. You know, just roughly broom it across the surface. It may help to work at a 45-degree angle depending on the paver type, but we want to make sure that that polymeric sand is falling into those joints, and we're getting it, you know, as filled as we can with that broom.
Yeah, and then the important thing is it's okay to leave a little bit of sand on the surface, because as we get into our next steps, we're going to have to re-sweep that sand most of the time.
Right. That next step of compaction is actually going to drive that sand down deeper into the joint. We're going to need to add sand anyway, so if there's some left on the surface, not a big deal. I often hear people say, oh, I want to clean it all off so I don't scratch the pavers, right?
Yeah. The polymeric sand won't damage the pavers. It's actually laying a little bit of a buffer between your compactor and the paver itself.
Right. I've often found that having that underneath the plate compactor almost acts as like a little rock tumbler polisher on the paver surface and helps clean things up. So no need to sweep it clean at first. You know, get the entire surface covered roughly with polymeric sand. It should look like your day at the boardwalk at the beach. I think that's why Eric came to New Jersey. He wants to go to the beach.
Yeah, I wish it was a little warmer.
So get that all spread out. Once you have all your polymeric sand spread out, you're going to run a compactor on it.
Yep.
And you have to compact any polymeric sand installation, right, Eric?
That's right. So whether it be pavers, whether we're working with natural stone, porcelain tile, whatever it may be, as a sand manufacturer, we're going to tell you that sand has to be compacted or consolidated somehow. You can see in this video they're using a roller compactor. That's the best method for compacting and consolidating that sand.
And hey, if you don't own a roller compactor, you're worried about breaking a more fragile material like a larger slab, wet cast, or natural stones, you can certainly use a hand tamp, a rubber mallet. Anything is better than nothing when it comes to consolidating those joints and making sure that that sand is densely packed.
Right.
You know, when you build a patio and you're installing your base, you're not going to skip compacting that modified stone, are you?
Yeah. The idea is you want to lock that stone together when you're compacting the base. Same thing here with the polymeric sand. We want to lock the aggregate in with the polymer.
Make sure those angular particles all mesh. Make sure they're touching. They're not spaced far apart. We don't have void space, and we're going to get a nice, strong, impermeable joint when we activate it. So when we actually sweep our polymeric sand into the joints, let's pretend for a minute that all these wooden blocks are actually sand particles, right?
Yep.
So they're spaced pretty far apart, aren't they, Eric?
They are. And even on a wide joint paver, they're still spaced very far apart.
Right. So we've got these polymeric sand particles. They're spaced pretty far apart. If we were to activate it like this, well, the bond between the particles isn't going to be all that strong. The particles aren't going to transfer the load from one piece to another all that well. And you're going to have a lot of void space for water to get in.
Right.
What did we just spend most of the show talking about?
Yeah, water.
Water.
We don't
problems
want
with water, right? So we don't want problems with water. What happens when we compact, Eric? Run that compactor.
Right. So we run the compactor over it. Everything consolidates and tightens up in that joint. So that aggregate, again, is locking in tighter with the polymers in that joint.
Right. So now your angular particles are tightly meshed together. They're going to mechanically interlock. You're going to have much stronger bonds between the polymer and each sand particle. And you're going to have much less void space to, have any kind of water infiltration. So that compaction gives you a denser joint that's stronger and more water resistant. Those all sound like good things, right?
It really is a critical step in your polymeric sand installation.
All right, so take a look at this video, right? This is a column of sand, right? A pretty good column of sand. We run that vibrator, that compactor on it, and it settles down quite a bit. So that's what you are missing if you don't compact, right? You've got to run that compactor. You've got to pack that sand down densely into the joint in order to obtain the right results. If you don't do that, you're physically missing product that should be in those joints. You're missing polymeric sand that isn't there. Your joint's 30 to 50% weaker than it should be.
Right.
So
you have void spaces in that joint.
as tempting as it may be to just sweep that sand in, sweep it off and activate it, you're doing yourself a disservice. You're not getting the strength and longevity that you should out of an Alliance Gator product without compacting. All right.
We talked about sweeping. We talked about compaction and how critical it is. Next up is your joint height. This is another common occurrence we see. Is
Yeah,
overfilling the
I would
joints.
agree. I mean, over and over again, I hear when I tell a contractor that their joint is filled too high. Oh, that's the way the homeowner wanted it.
Right. Yeah. We have to remember what we talked about at the beginning. The polymeric sand is not designed to be mortar. It's not designed to come in contact with foot traffic, patio furniture, tires, whatever the case may be.
So take a look at our little example here, right? I see this on job sites all the time, Eric. Totally filled up to the top edge of the paver, the chamfer's filled up. That's a really big problem.
Yep. There's a couple things that can go on here. One, like I just talked about, this contact with the surface. If that crust does start to peel away due to contact, we have less and less setup material in that joint.
Right. So that's definitely a problem. Polymeric sands also expand a little bit during that cycling process. When they get wet, they soften up and they expand. So if you've installed that polymeric sand flush with the surface, it might look okay the day you install it, but when it gets wet, it's going to swell up above the paver surface and not only be subject to potential wear and tear from foot traffic or vehicular traffic, but as it rises above the vertical portion of the paver, it's trying to rip itself away from the paver. And as it does that over and over and over again, it's eventually going to succeed.
Yeah, it's going to rip itself away eventually.
So we need to have that joint height down low enough. And what is low enough, Eric?
Right. So we say 1/8 of an inch below the chamfer of the paver. It's important to remember, different pavers have a different type or different style of chamfer. If you have one, like a rounded paver, for example, it needs to be below 1/8 of an inch below basically where that flat edge begins and ends.
We always want the polymeric sand to remain in that vertical channel that you see on screen there. And the other thing I notice, that kind of looks like a funnel shape, Eric.
Right.
Does that do us any good?
It certainly helps us, yeah. So what we want to do, we'll get into watering next and activating the sand, but we want to create a reservoir for that water to sit in. And what that's going to do is allow that water to penetrate down deeper and deeper into that joint. If the sand is filled too high, a lot of that water will run off the surface rather than penetrate down in the joint.
Right. So, it's very important to set that joint height properly. I think pavers look better when the joint height is set lower, right? We're putting in interlocking concrete pavers so that they look three-dimensional. If we wanted a single dimension, we could just pour concrete.
Yeah, that client is paying for the pavers. They're not paying for, well, they are paying for the polymeric sand, but that's not.
I hope so.
Yeah, that shouldn't be the main focus of your project.
All right, so we've got to compact no matter what, one way or another, whether it's mechanical or hand compaction and consolidation of that polymeric sand joint. It's vitally important to set that paver joint height. Now, some pavers that's easiest by broom, some pavers that's easiest by blower. but make sure that you're getting that sand joint height set 1/8 of an inch below the start of the vertical channels of that joint. All right, so we've got our joint height set properly. Anything else we need to do?
We need to activate.
We need to activate it. So once we have the joint height set properly, our surface is nicely cleaned off, we are ready to activate the polymeric sand.
And this step is very important because this is what will vary the most when you're looking at one product to the next. Is the water application, the activation process.
The first polymeric sands, well, they said mist it lightly and walk away. You'll wash out the polymers.
Right. Not the case.
If you mist any product on the market today, you're going to end up with a very thin crust that is prone to failure. You need to water it a lot more. Most products on the market 5-10 years ago were a 3-step watering process. So you would water it once relatively lightly to make sure that you started activating the surface. It became gummy and cohesive so that you could do a second and third successive watering, heavier waterings, to help get water to penetrate down deeper, while that initial activation kept the product from washing out of the joints.
The newer sands, specifically our G2 product, is a 1-step watering because it has that rapid set technology in it.
And not only is it a 1-step watering process, but if you do the 3-step process, you're going to have some trouble. That rapid set technology is in there to make the product rain safe in 15 minutes. The polymeric sand starts becoming gummy and sticky and cohesive very, very quickly. In fact, I've seen it in 2 or 3 minutes, not 15.
On a hot summer day, that sand will start gelling up and being cohesive in a couple minutes.
So with the G2, we need to water it in one shot. 30 square feet for 30 seconds is kind of our tagline. We want to make sure we get enough water on the surface that it can soak into the joints and activate the polymeric sand down deep enough to obtain the crust that we want. So we want to get at least 1.5 inches down in that joint.
Yeah, it's important to keep that water on the surface until it starts repelling the water.
So let's think about it. We need to have our joint height set low enough that the water can gather in the joint and soak in rather than run off. We need to make sure we're adding enough volume of water. As Eric was just talking about, we're going to water to the point of water retention and rejection. We don't want to see a ton of water running off the job, but water it until there's water puddled and ponded on the surface. It's not going to cause a problem. That white foam that you see there, Eric, is that going to stain the surface?
That won't. So all that white foam is that's a surfactant. That's not the polymer. It's a surfactant, which is basically a soap. It's lubricating the sand to allow the water to penetrate at a quicker rate and deeper into that joint.
Right, so that little bit of foam is not a problem, not an issue at all. That's just designed to help the water penetrate down deeper. That's going to dissipate as the surface dries out. So you need to make sure that you're working in those small, discrete areas. Get enough water into that 30 square foot area to activate it deeply enough.
Yeah.
Paver joint width also matters, right, Eric? If we're talking about a Holland stone, well, hey, 30 for 30 might be a little bit too much. If we're talking about your typical 3 or 4 piece system that's got a 1/4 inch wide joint, 30 for 30 is probably perfect.
Yeah. You get in some of those larger joints even, you may have to go 30 for 10. The point is, you want that water, you want to give it water until it starts to pool and puddle in the joint so it can penetrate down into that joint.
And inevitably, whenever we're doing a demo with G2 or we're out helping on a job site, the contractors always think, wow, that's a lot of water. I've never seen anyone put that much water on a polymeric sand job.
Yeah.
And that's just the difference in the technology and the installation methodology. So with the G2 polymeric sands, make sure you're doing that 1-step watering process. Just take a look at the back of the bag and check the watering.
Yeah, and one other thing I see quite often, particularly on driveways when we're working with a lot of slope, you want to start at the bottom of that driveway or at that slope and work your way up.
It's a very good point, right? We want to make sure that the bottom is activated so that any water that's running down from, moving up the slope doesn't prematurely activate or wash out anything below.
Right.
So work from the bottom up on a more significant slope. All right. Well, that was pretty good, Eric.
I think we covered it.
I think we got a lot of great information out there. I see a question, can you overwater it at all? Sure, you can overwater polymeric sands, but I would say that if there were 10 polymeric sand jobs out there, 9 of them are underwatered.
Right.
Maybe 1 is done correctly and none of them are overwatered. You'd have to be super saturating that joint, causing excessive runoff. One kind of issue to look for and be careful of would be any kind of concrete overlay or a stone dust job, right? If water can't drain out the bottom, well, you're more likely to cause an issue by adding too much water. But on a sand or a chip setting bed, it is very difficult to overwater a polymeric sand joint. What is your solution for sanding pavers with narrow gaps? Well, as long as they have a spacer bar,
Right.
you're going to be able to get polymeric sand in there. Now, it might not just be 1 pass with a compactor to fill that joint from top to bottom. It might take 2 or 3. But as long as there's a spacer bar, you can get polymeric sand in there. Now, if there's no spacer bar and they're butted up tightly together, your travertines or clay brick, that can be tough. You might have to look at maybe using a very fine sandblasting sand or something along those lines instead of a polymeric sand.
I think the idea is in that situation, a roller compactor always makes it a little bit easier, but like Mike said, you may have to go over that 2, 3, 4 times.
All right, so how about using fine sand as a bedding layer? Well, ICPI recommends coarse concrete sand for 2 reasons. 1 is the structural stability, and 2 is the drainage aspect of it. So fine sands typically do not have the structural integrity of a coarse angular concrete sand, and they definitely don't have the drainage. So you're going to cause some issues with using that bar sand or mason sand or ASTM C144 gradations as your bedding layer. Let's see, what else do we have? Minimum temperature for application. How about that, Eric?
37 degrees. You don't want to
32 degrees, 37 for nitro.
32 degrees. You don't want that joint to freeze.
You typically don't want your water to freeze while you're activating it, right? So let's use some common sense here, right? If it was 8 degrees the night before and you're coming out in the morning to install polymeric sand, odds are your water's going to freeze and create an icy mess all over the place. But polymeric sand's pretty forgiving. If you installed polymeric sand and, hey, 8 hours later, it got dark, it went below 32 degrees, well, the drying reaction is going to stop, the curing reaction is going to stop, but the next day when it warms up, it's going to start again. Polymeric sands cure by drying. It's not a chemical reaction like concrete, so we can't give you a time frame. I can't tell you, hey, Eric, your polymeric sand's going to be set in 6 hours every time, no matter what.
It's going to change from job site to job site, from one weather condition to the next.
Right. In Arizona in the summertime, hey, polymeric sand probably cures in 30 minutes. But in Chicago in the wintertime, it might take a month in order for it to fully and properly cure, which is not really an issue. Best method to minimize haze. Well, I'd say the best method to minimize haze is to buy an Alliance polymeric sand product. All kidding aside, 10 years ago, 15 years ago, haze was a real problem in the polymeric sand industry. If you didn't follow the instructions exactly and have bone-dry pavers before starting the installation process, it was quite likely that you would turn your beautiful new pavers a slightly dull shade, whiten them a little bit, but polymeric sand haze really doesn't happen. In the G2 with rapid set technology and our regular products that have advanced haze-free technology, we use clear polymers. They're very advanced. Your likelihood of having any kind of haze is very, very low. I always recommend using a blower, to get any remaining dust off the surface before activating, and then taking that leaf blower on idle afterwards and just getting any excess water that may have puddled or ponded, especially on textured pavers, off the surface.
That's what I was just going to say. On a textured paver especially, because when we're using as much water as we're using, a lot of times, a lot of that dirt and the excess sand residue can sit in those lowered dimples of the paver.
All right. Why does G2 swell out of the joint? Well, as we talked about, G2 and any polymeric sand can swell up when it's wet. In fact, it will swell up, not it can swell up. So we need to make sure that that joint height is set low enough so that it doesn't swell above the surface of the paver. During the initial activation, swelling above the surface could be a sign of overwatering. So, hey, as we talked about, if you have a sand setting bed, a chip setting bed, probably not going to be a problem. It's going to drain out the bottom instead of pushing back upwards. But if you've got a non-drainable base, your stone dust, concrete overlay, that water may start reflecting back up and may push the polymeric sand up with it.
Right. And again, if you're up against a wall where you have a layer buried and that water can't drain out, that could be an issue too.
All right. I saw a question in there about polymeric sand versus maximum slope for polymeric sand. Well, if you're comfortable walking on it, I would say you're good to install polymeric sand in it. There's really no maximum slope for polymeric sand. But there are cases, there are circumstances where erosion can be an issue with polymeric sand. Think about water dripping off a deck or from a gazebo or house with no gutters, right? Polymeric sand's tough stuff, but it's not meant to withstand constant erosive forces falling from a pretty high distance.
And with the slope, if you are on a drastic slope, you do have to take that watering process a bit slower.
All right. Any other questions that we have here? Let's see. What is the best method to remove polymeric sand from the top of pavers if the pavers are damp or shaded prior to filling joints? Well, my recommendation would be not to install polymeric sand if the pavers are damp or potentially wet. Beyond that, your best bet is to hit it with a scrub brush and some water while it's still wet. You'll be able to get it off pretty easily. Once it hardens up on the surface, hot water and some saturation are probably your best bets. So maybe go out there after a rainstorm or put a sprinkler on the affected area, add some hot water to it, and scrub that polymeric sand off and rinse it away. All right. What are the advantages of using polymeric sand instead of nitro sand? Well, first, you want to give a quick explanation of what nitro sand is?
So nitro is our resin-based sand. So it's a wet install as opposed to a dry install. It's permeable and it hardens all the way through the joint.
Right. So in some ways, nitro is closer to a mortar joint. It's more rigid, it's strong, and it hardens up top to bottom, but it doesn't have the flexibility of a polymeric sand. So why would you choose polymeric sand over nitro? One, flexibility, right? Nitro has no flexibility. Polymeric sand, as we showed you with that sample, has quite a bit of flex to it when wet. Another is the joint width issue, right, Eric?
Yep. Yeah, so on a real narrow joint, nitro has to be a 3/16 inch joint or wider. So anything narrower than that, you have to use a polymeric sand because the nitro will never get down into those tighter joints.
Right, because the nitro is a wet material mixed with the resin, the binder, it doesn't flow as well as a dry granular sand. We're not compacting nitro into the joints, so that polymeric sand can get in a much tighter joint. I'd say 50% of the pavers out there are really appropriate for polymeric sand and not appropriate for nitro. Another application where you might choose that polymeric sand over nitro is a choice of economy. Nitro is a more expensive option than polymeric sands, just a little bit more expensive technology. Any other reasons you can think of?
No, that's all I can think of, really. I think we covered it.
Oh, permeability is one, right?
Well, yeah.
So nitro is a permeable joint material. Now, that can be a benefit in some cases, right? If you've got a well-draining hybrid base, well, water goes through the joint into your base material and dissipates. Hey, that's great. If you have a stone dust job, a concrete overlay, well, using a permeable joint material and letting water into that system is a bad idea. So you're better off with polymeric sand, properly compacted, good pitch on the surface, creating more of a runoff situation than any kind of permeability.
Yep.
All right, what kind of sand do you recommend for porcelain tile? That's a tough question. We really don't recommend any polymeric sand for porcelain tile, and that's because of a couple different issues. The first is stability with tile, right, Eric?
Yep. So porcelain tile, it doesn't have any spacer bars, so you're relying on the joint material to hold that project together horizontally.
Right. Tile are incredibly unstable, right? They want to shift and move underfoot. You step on one side, the other side lifts up. In my opinion, there's only two ways to successfully install porcelain tile. One is wet setting it to some kind of solid substrate, whether that's a concrete slab or a permeable material underneath. The other option would be our Gator tile system. Both solve that stability issue. The other problem with porcelain tile is that they're completely impermeable. So a tile almost ends up being a vapor barrier. The only way for moisture in or out of a tile project is through the joints. And with that moisture moving in and out of the system through the joints, it doesn't allow that joint to cycle in many cases with a polymeric sand. So Our answer for tile is nitro, but only with the Gator tile system that provides you that stability.
Right. The Gator tile system, in conjunction with the spacers we use, prevents those tiles from wanting to shift left and right.
And it's a much more in-depth topic. You know, feel free to reach out to your local Alliance rep if you've got any questions on installing porcelain tile and the right joint material to use for porcelain tile. Maximum joint width for G2. Well, there's a corporate answer and then there's my answer. So with G2 Gator Max, you can do up to a 4-inch wide joint. But I really think that once you get beyond about an inch or so, a polymeric sand joint starts to look unnatural and kind of goofy. You're much better off switching to our Gator dust once you get beyond an inch. You know, there's no concrete paver that's got a joint wider than an inch, so we're probably talking about a regular flagstone, something along those lines. And the Gator dust product, which can do joints up to 6 inches wide, has a stone dust texture, really looks much better and performs better.
It's important to remember with Gator dust, though, that we still have to compact, so that Gator dust still has to be consolidated, and we still have to be below the edge of all those stones. So whether it's 1/8 of an inch, 1/4 of an inch, that's going to depend on the thickness and variability of your stones that you're using.
Right, and it's 1/8 of an inch below the lowest point.
Right.
So we're not going 1/8 of an inch below the highest point and then ramping up over the lowest point. You need to make sure that it's 1/8 of an inch below all around. And another issue with flagstone is stability, right? Hey, hardscape products are getting more and more expensive. I see more 3/4 inch flagstone being sold at dealers than ever before. And a 3/4 inch thick piece of flagstone, especially when it's only the size of a dessert plate, is not very stable. So we want to make sure that our stone is stable before we put that Gator dust in the joint. You know, the Gator dust isn't meant to glue the project together. We need to have proper edge restraint and stable stones well bedded in a concrete sand in order to have a successful joint installation in flagstone.
It's important to remember that as that stone tends to move, your sand is going to fail over time.
All right. We were a little bit all over the place with those questions, but again, if you have any further questions, please reach out to your local Alliance rep. If you don't know them, ask your dealer. They'll put you in contact. We love to educate. We love to teach contractors everything we know and try to make sure that you have success and never encounter, some of these issues that we've seen in our travels here.
Yep.
All right. Have a great afternoon, everybody.
Thank you.